And as I said, you could just move this to the outside. Yeah, move it to the outside. So 1 times x times sum of f of x. Sum of f of x. So whenever you multiply any, so 1 to the power x, so no matter how much, whatever the power you put in over here, it's just going to be 1 times 1 times 1, whatever. So it's always going to be 1. So this is going to be 1, and the sum of the frequencies is going to be 1. So g x of 1 is going to be 1. However, what if we differentiate it? So I'm not really sure how to. So d dt, and then we do that for t f of x. So if we differentiate it, we're going to get the sum of x. So here we just move this down and we subtract 1. So xt x minus 1 times f of x. So this is going to be g prime of x, or the first derivative of t. As I said, the t is always going to be 1. So gx prime of 1 is going to be sum x times 1 to the power x minus 1 times f of x. Oops. So this is going to be 1. And if you are familiar with this formula, just ex. Now, you might be thinking that's dumb. Why do you go through all that effort just to get the expected value of x? Now, the point is, if you have a complicated formula, then it would be extremely easy to get the expected value by just differentiating it. And that's the same thing with the moment generating function. So it looks weird, but when you differentiate it, it's extremely simple, and you don't need to do any arithmetic with x, with e of x. You could just differentiate it to get the other values, to get the mean and the variance. So now let's try getting the variance. So let's reverse engineer this formula. Let's go to here. So let's try reverse engineering this formula. Okay, first g double prime of x. So g double prime of t, not x. Okay, this is going to be the sum of t, to a derivative, d squared dt squared, and then the sum of t times f of x. So over here, you get the derivative 1, so it's going to be tx minus 1. Then you get the derivative again, it's going to be x times x minus 1 times t x minus 2 times f of x. Then, yeah, e, sum of this. So as we said, we're always going to be passing in 1 st, 1. So this is going to be 1 as well. So it's going to be sum of x minus 1 times f of x. And this is just the expected of x minus 1, or the average of this. So as you can see, we get the second derivative and we get this formula. Now you could see that the variance, they give you like some weird formula, but let's break it down. So let's look at this formula first. Oh, I didn't drive that. So let's look at that formula first. So variance of x is equal to expected value of the average of the squared distance between x and the mean. So x minus mean squared. So let's derive this one first, then let's look at the other formula. So we expand it. So e x squared minus 2mx plus m squared. Now m is the mean of x. And now we could split it among the. You could try it for yourself if you doubt this, but yeah, let's just expand it to the sum. So x squared minus 2mx times x plus m squared. This is all times by f of x. So then we could do a distributive property. So sum of x squared times f of x minus or plus sum of negative 2mx times x f of x plus the sum of m squared times f of x. Now we could bring the constants outside. So we could bring the constants outside, and then we could do this. So what is this? It's just the expected value of x times negative 2m mean plus, and this is just going to be e x squared. Now this is going to be e of m squared of x. So as we said before, f of x is going to be 1. So we could just say that this is m mean squared. So now you might be seeing like the formula is coming along, but over here it says mean squared plus mean squared, and this is ex squared like over here, but there's this part and this is plus. So what do we do? So this is just the mean. Okay, e of x is the mean times mean of x times negative 2. And this is mean squared, so that would result in, so negative 2 plus 1, that's going to be negative 1. So negative mean squared of x. So ex squared minus mean squared. And this is just ex squared minus ax squared. Or you could say it's the second moment of x minus the first moment of x. And when you do this in MathCAD, it's extremely simple to do. So now we derive this formula. Now let's look at this one for the probability generation function. So as we said, did I mention that? So as you can see, g double prime of x. So as you can see, it's expected of x and x minus 1. Now for the variance, now we said that this is the variance. This is the second moment minus the first moment, but it's not that relevant here, but in MathCAD it would be. So now we want to create this formula into this one. So g of x double prime 1 plus g of x prime 1 minus g of x squared 1. So g double prime is going to be x minus 1 plus g prime of x is expected value of x, so ex minus gx, this is all squared, so this is ex squared. Now you might see like there's some similarities. So ex squared and the mean squared. And this is the mean squared. So that means that ex squared is equal to this. So now if you expand it, okay, so ex squared minus x plus ex. Now you might see something forming. So ex squared minus ex plus ex. Now this all cancels out to 0. So it's simply ex squared minus ex squared. So these two formulas, they're exactly the same. And as we said, the formula is just the sum of t to the power x times f of x. So if you wanted to just change it into the probability mass function, then the x is here and the frequency is just multiplied on the side. So frequency, then x. So here the frequency is 6 over 15, x is 2. Now for the moment generating function. So as I said, the expected value formula is most important in the chapter. So here we just pass in e to the power tx, and this is going to be the sum of e tx times p fx. Again, you just take in e of x, then you substitute e tx over here. So now you, as with the probability generating function, yeah. As with the probability generating function, the moment generating function is from the name, it generates moments. So instead of trying to mess with this stuff, okay, as you can see, like second derivative plus first derivative minus the first derivative squared. So that's kind of confusing. So this formula, okay, it is directly getting the moments. So when you get the derivative of it, so e so this is the moment generating function. Now let's see how it generates moments. So as I said, mx t. Now for the probability generating function, you always pass in 1 as t. It's the sum for g of x. So you're always going to be passing in 1. However, because that would make it 1 to the power x, and that would just be 1. So you could just ignore that. Now the same thing with the moment generating function. So they just put e because that's simple for it to get the derivative of. So now here, mx t. So you're always going to be putting 0 inside it. Now you're going to see y in a minute. So let's say sum of e tx times f of x. Now pass in 0. So instead of t, it's going to be 0. So this is all going to be 1. So this is going to be the sum of f of x, or e of 1, or x to the power 0. And as we said, x to the power 0 is similar to x bar, so r is going to be 0. So this is going to be, you could say it's the 0th moment, but I've never read anything saying that. Now let's go on to the derivatives. So as you see, even though there was e inside here or anything. Okay, so you might think that they put e here so it's more complicated, but in reality they put the e here, makes it much more simpler. So now let's get the derivatives. So mt. Now we don't do derivative in terms of x, we do derivative in terms of t. So d over dt. So let's get the first derivative of etx times f of x times dt. So now when we get the derivative of this, e to the power tx, all we do is we put we just put this in beside it. So it's just going to be sum of x times et. X times f of x times f of x. So where did I put this here? So this is going to be mx of 0. Now moment generating function of t. So instead of t, we put 0, and as we said, we put it there so it's simpler. So e to the power 0, even though it's times x, is also going to be 0. So e to the power 0, anything to the power 0, is going to be 1. So you could just ignore this. So it's just going to be f times x times f of x. So as you can see, this is first the derivative of the moment transiting function. So as you can see, this is x times f of x, or you could say that it is, so mx of 0, you could say that it is the expected value of x to the power 1, first derivative, which is equal to the first moment of x. So all these are linked together. Now, what if we get the second derivative? So all we do, x times etx, then we get the derivative again. So it's going to be x times e of x, t of x. So this is going to be 0, then f of x. So it's just going to be, so you got the second derivative, so it's going to be x squared f of x, and this is going to be ex squared, or the second moment. So as you can see, if you get the derivatives, it gets the moments. So first moment, and this is the second moment, aka the moment generating function. So I hope you got that.